Alright, hello guys. Welcome to part 2 of graph and rational functions. Today we're actually going to take the functions that were in the video on, on Friday, I guess it was, and actually graph them. Again, I also posted solutions for the homework, the assignment you had yesterday, and I'm also going to post pictures of the graphs I'm going to sketch here today because the actual pictures you might see a little bit better than the sketches I have. But yeah. Joe, just a reminder of what's going to happen this week. So you have this lesson to watch today, Google form to fill out. Please, this is your time to ask any questions you have on anything you don't get on this lesson, the lesson before it. Then tomorrow you'll have an assignment on this to kind of like graph on your own. I'll probably post those answers later that day, probably like right at the end of the day around 7, as well as posting the answers, I'll also post kind of like some practice questions like before at the beginning of the day for the quiz, and you're gonna have a quiz on graphing rational functions on Thursday on quizzes, just like we had our test. Okay, and this will still be a third quarter grade. Okay, so I'm not gonna go through finding. I'm gonna not go through A and B because you already can go back and watch the video if you don't remember how to find the x-y-intercepts or the vertical asymptotes. Okay, but you have to find those first, of course, when you're graphing. Okay, I'm just doing this also use these problems to keep the videos a little shorter. So part C, people were having trouble on finding the horizontal asymptote. So the horizontal asymptote, of course, is a line that's going to go this way, right? It's horizontal, it's going to go this way. So that's why it's a y equals line. Y equals lines go this way, x equals lines go this way. So it's always going to be a y equals line, meaning it's going to be y equals something. Either y equals 0, which is the x-axis, y equals a number, or it's not going to have a horizontal asymptote depending on the rule. So here's the rule as follows. N and M, N's on the top, M's on the bottom. N is the highest powered exponent of a variable at the top. M is the highest powered exponent of a variable at the bottom, okay? In order to find the horizontal asymptote, I need to look at, okay, so in this case, so let's say there was no variable at the top, right? Let's just say it was like 9 on the top, right? 3 plus 6 or whatever. Then that means M would be 0 because there's no variable up there with a power. So if there's no variable at the top and there's a variable at the bottom, that means N would be less than M, and so that would mean the x-axis is the horizontal asymptote. If the power is less on the top, the highest power variable is less on the top, which if there's a whole number it's 0, then the horizontal asymptote is the x-axis. Okay, then if they're equal, like we have here, then your horizontal asymptote is going to be y equals the numbers in front of them. So that's going to be 3 over 1, which is 3. So my horizontal asymptote in this case is going to be y equals 3, like we went over. If the highest power up here was bigger than the one down here, then there would be no horizontal asymptote. Okay, we might see a little more of those as we go through these problems. Hopefully that makes more sense. Again, you just got to practice. Okay, so again, the rules. If n is less than this one, if it's less, so if this is like, if n is 0, because the highest power of the variable is 0, if there's no variable, or if it's like this is 1 and this is x squared, you're looking at x or whatever variable that is, then the horizontal asymptote is the x-axis. So again, that's the top bigger than the bottom. If they're equal, you just divide the numbers in front of the highest powered variable, okay? Then if this one is greater than this one, then there is no horizontal asymptote. So you kind of got 3 ways to look at it, okay? I'm only going to go through that in depth once. I'll kind of explain as we go through it again. But all right, so now we're actually going to graph these. Okay, so the first thing I'm going to do is I'm going to draw my coordinate plane, okay? And I'm going to draw in all my stuff, okay? I'm going to show you how to draw asymptotes and stuff like that. All right? So we got this here. All right, so let's first all plot my x-intercepts and y-intercepts. So my x-intercept is 0, -6, so I'm going to go 1, 2, 3, 4, 5, 6. There's that one there. And then my x-intercept is going to be -2 to 0. So I'm going to go -2 and then stay on the x-axis 0. All right, so there's that. So there's my 2 points. All right, now I'm going to draw in my asymptote. So my vertical asymptote, x equals 1, it's a line that's going to go vertically up and down on x equals 1. So I'm going to draw a line here. I'm going to go There's my vertical asymptote, x equals 1. And my horizontal asymptote is y equals 3. So I'm going to draw on a different line. I'm going to go up 3, 1, 2, 3, and I'm going to draw my horizontal asymptote, okay? It's kind of as straight as I can be. All right, so here I'm going to have two kind of regions. I have this region over here. Basically, I want to go on either side of my vertical asymptote. When I have two of them, I have to go on, I'm going to do a little more. I'm going to have that next in the next problem. In this case, I have one vertical asymptote. So if I only have one vertical asymptote, I want basically only 1 point on this side to the left and 1 point to the right. Okay, well in this case, we already have actually 2 points to the, the left. So actually, I can already draw my first curve. I'm going to do that with this color here. So my first curve, you're going to get really close to your asymptotes because an asymptote, remember, is a point it's almost going to hit, but it's never actually going to hit it. So I'm going to get really, really, really close to here. I'm going to draw my curve. It's going to kind of go down like that. And that's a really bad depiction. Let me redraw that. All right. It's going to go something like, it's going to kind of go, it's going to get really close here. It's going to get really close here. And it's just going to kind of go down. Sorry guys, I'm just going to, whoop. Something like that. Again, rough sketch, but it's going to get really close to that one, really close to that one, but never going to get there, okay? Now, okay, so that's my first curve. It's actually going to be two pieces to this graph. So there's going to be a curve on this side as well. How I'm going to figure that out is I want to get usually one number on the other side of 1, right? So, well, the next number next to 1 is 2. So what I'm going to do is I'm going to find f of 2. When I find f of 2, 2 would be my x coordinate, and then my y coordinate is going to be whatever answer I get. So if I plug 2 into this function, right? So if I find f of 2, if I plug 2 into for x here, I'm going to actually get 12. Because that's 3 times 2 is 6, plus 6 is 12. 2 minus 1 is 1, 12 over 1 is 12. So this would make the point 2, 12. And again, I'm just doing that because I already had points to the right of it, so I'm good. But I still need I need to do the point to the other side. I need to do to the left. I already did to the left of it. I need to do the right of it as well. So I just picked one number to the right is 2. I plugged it into the function, and I got the answer of 12 when I plugged it in. So I'm going to plot the point 2 to 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to plot this point. All right, so there's 2, 12. All right, so now I'm going to draw this curve as best I can. And it's going to get really close to here and really close to here, but it's never actually going to touch. So there's my two curves. So again, these graphs are always going to have 2 to 3 kind of curves or parts of them. In this case, this one only has 2. These are probably your easiest graphs you're going to see. So again, it's going to get really, really close to those asymptotes, but it's never going to actually touch the asymptotes. We have 2 curves here, so I'm on either side of my vertical asymptote, and that's it. There's my graph. And again, the reason I picked 2 was because I wanted a point. You only need, when you're drawing these curves, you only need really 1 point. So I picked 1 point. I already had 2 points to the left over here, so all I had to do was draw the curve, and I just get really close, and then I did 1 point to the left, and to the right, excuse me. And again, you don't need to get crazy when you're drawing these. Again, if you're doing this assignment, just sketch them best you can. And of course, on the quiz, you're just going to get pictures of graphs, and you have to tell me which one it is. All right. So that's the first one. Alright, so that's my first one. So again, 2 was not random. It was just one number to the right of 1. Alright, so my next 2 graphs are going to be a little tricky because they're not only going to have 2 parts to them, they're going to have 3 parts. So we're actually going to split this graph into three parts. Alright? So the second function, if you go back to the video we did on the other day, it's Friday I guess you'd say, this was the next function, right? So the function was, so I'm actually going to have you guys add these to your notes from Friday. Because it's the same thing, we're just adding the graphic. But I want to teach you guys how to do it first. Okay, so we found here that this problem had no x-intercepts, okay, and had a y-intercept of So x-intercepts are none. We have none. The y-intercepts were 0, -1. This is the y-intercept. Okay, then, after that, we figured out that there were two vertical asymptotes, 3 and -3. And my horizontal asymptote, again, we see that the highest power down here is bigger than the higher power. This is n is 0, m is 2, because it's the highest power of x. So because of that, my x-axis, or the line y equals 0, is my horizontal asymptote. Alright, so now let's get to graphing this, alright? So, there's actually going to be 3 parts to this graph. We're going to see, because as you think about the last one, we're going to see how we divvy this up. Alright, guys? So, alright. So my first thing I want to do is graph my intercepts. I'll graph my y-intercept there. So that's just going to be 0 to -1. I'm going to graph with this one. So 0 to -1 is just going to be here. So there's that. Now I have my two vertical asymptotes at 3 and -3. So I'm going to draw those in. So I'm going to go over 1, 2, 3. And they're always going to be dotted lines, okay? I'm going to draw these dotted. And then I'm going to go over 1, 2, 3 this way. Alright. And then my y-axis, so the middle line there, basically your x-axis, sorry, that's my x-axis, is my horizontal one. So it's going to get really close to this, but it's never actually going to touch that. Alright, so in this case we got a little work to do. Because what we're going to end up having is we're going to have 3 parts. We're going to have a curve kind of like up here, a curve kind of like here, and we're going to have some kind of thing going on in the middle, and that could differ depending on the problem. Alright, so let's look at this. Alright, so what I want first is I want to get 1 point to this side of the graph, alright, to the left of -3. So what I'm going to do here is I'm actually going to erase this side. You guys have this hopefully from the other day. Alright. So I'm going to find one coordinate, so I'm going to use -4. That's one number to the left of -3. This is -3. I'm going to do one number. I'm going to find the point when I do f of -4. Okay, when I do that, guys, when I do f of -4, I need to figure out, so I know it's 9/7, I just want to put it in decimal form. You're going to get about, you can round that if you want to. You're going to get 9/7, or about, I would say 1.3. That's probably fine. Again, we're just trying to sketch it and get a good idea of what it looks like. So f of -4, when I plug -4 into the function, I'm going to get about 1.3, okay? That's approximate, not exact. It's like 1.28, something 9/7, okay? So when I find f of -4 is here on this side, right? So I'm going to go -4 to about 1.3. So if this is 1, this is 2. So I'm going to go a little bit above 1. And again, I'm going to attach nice pictures of these graphs. And then what I'm going to do is I'm just going to kind of sketch my curve, right? So I'm going to get really close to here and really close to here, but I'm never going to touch it. And that's my first curve, okay? You only need 1 point for these curves, okay? So I'm going to do this outside first. Just go 1 point to the left. All right. Now on this side, I'm going to go 1 point to the right. Okay, so this is 3, right? So I'm going to go 1 over. I'm going to go to +4. Okay? So I'm going to do this side, right? So I'm going to do this side. It's going to probably be another curve looks like this, but let's see. So if I do f of 4, I'm actually going to get the same thing. I'm going to get about 9/7 or 1.3, which is also, I'm trying to show you it is 9/7, but you should have it in decimal form. You can round it to the nearest tenth. Again, it's just a sketch. So now I'm going to take this back to about the same point. I want to draw it there. And I'm going to draw my other curve again. Again, asymptotes are getting closer and closer and closer to that value, but you never ever get there. And those should look about identical. You'll see it in the other picture. They're about identical. Alright, now the middle is where it gets tricky. So yes, I understand we already have 1 point. We already have a point there. We already have this 0, -1. Can I just draw something? Now, this middle part of the graph is going to be different depending on the problem. So you have to figure out what the behavior is in between. So what I would do is I want to find 1 point to the left of that y-intercept and 1 point to the right of that y-intercept. I want to try and get as close to my asymptotes as possible. So what I'm going to do is, I'm going to do, my closest number here is -2 and 2. So I'm going to do that. I'm going to plug in f of -2. I'm going to do f of -2, and I'm going to do f of 2. All right? Because those are the closest numbers to my asymptote 3, the closest whole numbers, okay? It might not always work, but you just want to try and get as close to the whole number as you can. All right? So when I do this, all right, so f of 2 is going to be, if I plug f of 2 into this function, sorry guys, I'm going to get -9/5, okay? That's -1.8. So if I plug in f of -2 to the function that I just had up there, I would get exactly, actually, -1.8. And it's going to be the same answer actually if I plug in 2. So I plug in 2 or -2 into the function, I'm going to get -1.8. Again, why I picked 2 and -2? They're two numbers on the left and right of my y-intercept, from the y-axis, that are as close, the closest whole number I can get to my vertical asymptote. So again, explaining what I did was, I first dealt with the outside points, right? I did one number to the left of this vertical asymptote, one number to the right of this vertical asymptote, which was 4 and -4. Now what I'm doing in the middle is I want to see behavior on either side of this y-intercept. So what I'm doing is I'm doing the closest number on either side of this y-intercept to the vertical asymptote there. So f of -2 is going to be -1.8. So that's -1. Let's say this is -2. -1.8 is going to be a little bit lower, like there. And they're both actually going to go to about the same point. I'll try to draw them evenly. Alright, then what's going to happen is it's going to get a little, so I'm actually drawing a little bit closer because I want to make sure, I want to try and draw this as accurately as possible. Again, I'm going to send you a picture as well. Let's say -2 is a little bit higher. So it's up here, I kind of try to spread it out. So what's going to happen is, this curve is still going to get as close to these values as possible. So it's going to kind of like a really weird U, almost exactly like you're going to get like really close. And you're going to see it better in the picture, but it should almost look like, if I draw it right, my computer down for a second. If I draw this correctly, guys, you're going to see that it's going to almost look exactly like a U. So it's going to be like, it should go like this and down, and this and down. I know it's kind of weird, and then I guess the 1.8 is kind of like here. So if I spread them out, again, it's kind of hard to draw it exactly to scale. It's just like a sketch. But this is how your graph should kind of look. Something like a U, and you have two kind of curves there. So if you have two vertical asymptotes, okay, what you want to do is you want to find one point to the left of this one, all the way over here, one point to the right of this one. You should have two kind of curves. That's how it's going to kind of end up, always. They might also face this way as well. Depends on the problem. Depends on the behavior. Depends on where the point is. Depends on where the vertical asymptotes and horizontal asymptotes are. Then finally, the middle one, you want to find 2 points to the left and right of your y-intercept. Use your y-intercept, and you got to figure out the behavior of what it looks like. But in this case, this is your graph. This would be the graph of that second problem from Friday. All right. Okay, so let's do the last one. All right, so the last one from Friday, the third one there. So finishing off graphing them. All right, let's just get there. Sorry, guys. All right, so the last problem from Friday, you had f of x equals x squared minus 4 over x squared minus 4x. Okay? All right. So let's find, okay, so when we found this, right, we had two x-intercepts that were 2, 0, and -2, 0. We did not have any y-intercepts though. There weren't any. Right, and again, we did this on Friday. Well, this is in the video on Friday if you want to go back to that first. So there's no y-intercept to this graph. But then you do have you've got two vertical asymptotes we found. we found we had two vertical asymptotes, one at x equals 0 and one at x equals 4. This is actually the y-axis. And then finally we had a vertical asymptote. Again, the reason we found this, again, the highest powers of x, or the variable, are the same. So we're just going to do the numbers in front, which is just 1, because it's just 1x squared, 1x squared. So it's going to be y, always a y equals graph, 1 over 1, or just 1. Alright, so my horizontal slope is y equals 1. Alright, so let's try to kind of graph this out. Let's see what this looks like. Alright, so if we kind of start to graph this out, right? Let's just plot everything we know. Drawing all of it. So I know I have x-intercepts of 2 zeros. That's going to go here, right? 1, 2, and negative 2 to 0. So points there and there. Alright? 2, 0, negative 2, 0. Alright, I have no y-intercepts, so nothing to graph there. I have two vertical asymptotes. Now I'm not going to make the y-axis. This is the line x equals 0 because x equals 1. So I'm just going to highlight in blue. So we don't have any y-intercepts because that's our one. It's never going to hit there. This is one of my vertical asymptotes. Okay, so we can't. It's one of my kind of like barriers. And my other one is x equals 4. So I'm going to go 3, 4. And I'm going to draw my dotted line. Best I can. Okay, now I also have a horizontal asymptote at y equals 1. So I'm just going to draw, I'll use this color. I'm going to draw y equals 1. I'm going to go, so this is 1 here. I'm just going to draw. Okay. So really, again, we have three places. I know this isn't dotted, so it's a little hard to see, but we have vertical asymptote here, vertical asymptote here, horizontal asymptote here. All right? So here's what we're going to do. So the first thing we're going to do is we're going to, remember, find a point on this side of this vertical asymptote, so a point on this side, and then a point on the other side of this vertical asymptote. All right, well, in this case, our 1x intercept is already a point on to the left of this vertical asymptote. So I can actually draw this curve right off the bat. So this curve is going to get really close to here. I'm going to try and draw it as best I can. This board's not the most steady. It's going to get really close to here. It's going to come down like that and something like that. So it should get a little closer to the points up here. So it should actually come out a little more. So I redraw this. It should kind of like, if I drew this a little more to scale, so it would be like, if this is like 1 and this is negative 2 here, it should come like all the way out and almost like touch these lines. It should like get really, really close. It's going to get really, really close to these lines but never actually touch them. Okay? So that one side's already taken care of for. We already have a point over there. Now, but we do need a point on the other side of this vertical asymptote next to the 4, right? So what we're going to do there is we're going to do f of 5. All right? So f of 5, if I plug 5 in, so now I'm finding f of 5 here. I'm going to try and find the point over here. So again, to find a coordinate, you're going to plug in an x. So I'm going to plug in 5. I'm going to see what I get out. So I'm going to do f of 5 here. So I'm going to plug in 5 for x here. And when I do that, I'm going to get 21 over 5, which would also be 4.2. Okay, so I plug in 5 into my function. I'm plugging it into this. Plug in 5 for x, and I get 4. My answer, it spits out 4.2. So I'm going to plot that point. I'm going to do 5, 2. So this is 1, 2, 3, 4, 5. So it's going to be a little bit above 4. You can just kind of sketch it out as best you can. A little bit above 4. All right, so there's my other point. All right, now once I do that, I'm now going to draw this curve in as best I can. So it's going to be, so only one point there. So the two outside skirts are easy. You find one point, you should draw a curve, and it should kind of like be barriered by the two asymptotes, the vertical and horizontal, okay? So see how this is barriered by those two, this is barriered by those two. The middle is where it always gets tricky. So I have my x-intercept at this point. It's not a y-intercept, but either way. You have this point here, an intercept, in the middle here. That's at 2, 0. I want to find a point to the left, a point to the right of this, so I can figure out what's the behavior on either side of it. So what I'm going to do here is I'm going to find f of 3. So I'm going to find f of 3, which is one number over. And then f of, I'm going to do 1.5, which is a little close to 2. So if this is 1, I'm going to draw it a little more over. This is 1.5 here. This is 2, this is 3. Alright, so I'm going to plug, so when I plug 3 in, so I'm going to spin in 3, right? I'm going to put a 3 into that function. When I plot 3 in that function, okay, when I plop it in, I'm going to get like negative 1.7. Alright, I'm going to call it 1.6 actually. It's like 1.667, alright? Just round it the best you can. So I'm going to go, so if this is 3, right, I'm going to erase these. So this is 3 here, the little blue line. I'm going to go down to, here's negative 1, negative 2. It's going to go probably like right around, yeah, like around here. Alright, so my graph's going to kind of like curve down this way on this side of the graph. Okay, now let's see on the other side of 2 what happens. So here's 1.5. If I put 1.5 into the graph, it spits out about 0.5 or 1/2. So if this is 1, it's going to go a little bit below 1, probably like right here. And it kind of almost curves up. So if I really draw this line all the way out, so I'm going to get in front of the camera, it's going to look just like this. So if I kind of draw this to scale a little more, it kind of goes out a little more, so go up a little more. On each side, so instead of that U that we made in the other one, the graph kind of goes down and almost gets close to that one. And this way it kind of goes up. It's going to go past the vertical asymptote and almost goes. So that's the middle of the graph. So it almost makes like a curve up on this side of that intercept and a curve down on this side. That's why it's important to go on either side of that intercept, because you don't know if the behavior is going to be like a U or kind of like this curve thing where it increases this way but then decreases that way. So you have to kind of see the behavior on either side of that intercept. So that's why that middle part you always do last. This 2 sides are easy because you just 1 point over from this vertical asymptote, 1 point over from this vertical asymptote. Pretty easy. Or you might already have a point there. But in the middle, you don't know what's going to be the behavior on either side. So that's why you really have to make sure you do the middle last, and then you just kind of, I'm not picking points randomly. Again, I picked 1 point, I did 0.5 on either side of here, because 1 is equal to 1, and really that's not part of the graph, so I just did 1.5. But you should know kind of, if I were to graph functionally this, you should know like what the middle looks like. Does it look like a U? Does it look like this? So you gotta graph it, you gotta see. And I know this is gonna take practice, I know this isn't easy. That's my 3rd graph. So you really have 3 types of graphs. You either have 2 kind of curves in some form, 2 pieces, or you have 3 pieces, kind of like this or U. Alright? Those are the 3 types of graphs you'll see. So that's graphing rational functions, part 2. Hopefully horizontal asymptotes will make sense. You know, maybe practice them more day. Maybe you talked with a friend. Maybe you figured it out. I'm trying to help you as best I can. I know it's hard. I know this isn't easy to teach from distance. But you know, so you'll have an assignment on this on Wednesday, quiz on this on Thursday. Please email me with any questions. I'll try my best to help from a distance.